Hello everyone, this is Professor Brian Macon, your technology teacher, your calculator connection, coming at you live in recorded fashion. And I want to talk to you real quick here about using technology to solve a system of equations. Now usually in an algebra course you would look at introduction to systems of equations, where you'd have like two variables and two equations. For example, you might have like 2x plus 2y equals 6 or something like that. I'm just making some numbers up. And x minus 3y equals 4. So you'd solve this system. So you talk about a couple different techniques, one being what we call substitution, the other being elimination. Now, usually when we have a system that's this small, we usually don't use matrices, but we could graph, right? So we could graph this system. These are both linear equations. Their graphs would be lines. We could find their points of intersection. So what I want to do on this video is focus on using matrices, and we typically use matrices when the systems are larger than what I would call a 2 by 2, right? So this is two equations with two variables, or two variables with two equations. So I want to look at a 3-variable, 3-equation system. All right, so let's take a look at an example of a 3 by 3 system. I'm just going to make a quick dirty example here. So let's say we have 2x plus 2y equals 6. Let's say then we have x plus y plus z equals 1. And let's say we have 3x plus 4y minus z equals 13. All right, now in my prior videos, I talk about how the beauty of mathematics is in its application. So what real-world problems would we be applying a system of equations to? Now this video, I only want to focus on the use of the technology, so I don't want to delve into applications. So check out one of my other videos in my algebra series on systems of equations, and we'll look at, in those videos, applications, real-world scenarios. So let's say whatever real-world scenario we're looking at, we end up with this system of equations. Now, so when we're using matrices techniques, well, let me say this. Let me back up for a second. So if I was going to use the techniques of a 2 by 2, right, so we had this 2 by 2 system up here. Here we have a 3-variable, 3-equation system. So if I tried to use the techniques of substitution or elimination, this gets pretty nasty, or it gets pretty lengthy, tedious. So instead of going through that work in this video, again, I show that in an algebra video. I want to focus on technology. How would I use technology to solve this system? So I'm going to use a matrix technique. So the first thing that I would have to do is write the matrix in what we call a augmented matrix form. So basically the concept here is that I'm going to have a column that represents all the x coefficients, column that represents all the y, the z coefficients, and then the constants, let's say, what's on the other side of the equal sign. Now you see some textbooks put a dotted line here to represent the equal sign, but that's not standard. So here's our first equation. We've plucked the coefficients off. And again, remember, this is 0 because I'm missing the z term. Right? So there's a 0 times z there. So then I have 1x, 1y, 1z equals 1. That comes from the second equation. Then I have 3x, 4y minus 1z equals 13. So this would be what we call the augmented matrix. So the augmented matrix really is we have plucked off all the coefficients and put them in a condensed form. This is just an easier way for me to represent my system of equations. Now, when we do again the work by hand, we use what we call elementary row operations, where we can add two lines together, we can multiply one line by a number, we can flip, we can interchange any two lines in this matrix. Again, I don't want to delve into that by hand analytic work. I've done that in another video. But let's discuss the technique of using the technology. Now, normally, there would be two things that I would want to achieve. So if I was doing this work by hand, usually what we talk about is putting the matrix in row echelon form. So row echelon form typically looks like this, right? Typically what we want is we want to get the number 1 and zeros and then the number 1 and a 0 and 1. So we want what we can sometimes call ones in the diagonal. And then I'll end up with, let's say, other numbers here. I'm just going to write some letters in their place, right? But I could end up with, some number A, some number B, C. These could be different numbers. So this would be what we call a row echelon form. Now, if I were to go through the work of finding the row echelon form here, we're going to use a technology to find that, right? So let's look at how we would do that. So first of all, let me bring up my calculator. So I'm looking at a TI. Pretty much any TI is going to work this way. So the first thing I'm going to do is I'm going to hit my matrix key. Where is that? It's right here. Here's the inverse key. It's right above the inverse key. So I'm going to do second inverse, and it's going to take me to the matrix menu. And the first thing I want to do is I want to edit a matrix. So I'm going to hit my right arrow twice. And I'm going to edit a matrix. And I could pick any of these matrices. I'm going to pick matrix A just because it was the first one. So it wants me to specify the size. So I have 3 rows by 3 columns. And there's my, this is 3 rows by 4 columns actually. We have 3 rows and 4 columns for this matrix, right? All right. Excuse me. So that first equation was 2, enter, 2, enter, 0, and 6. That was my first row. Right? So if I look back at my board here, there's that first row. Right here, 2, 2, 0, 6. My second row is 1, 1, 1, 1. So let's type 1, 1, 1, and 1. And then my last row was 3, 4, negative 1, and 13. So 3, 4, negative 1, and 13. And keep in mind, while you're watching me do this, you could pause and follow along, right? Take out your calculator, follow along with me, and pause at any point in time you need to pause. So here's my matrix. Now the first approach is to get what we call the row echelon form. So the way that I'm going to do that, let me go back to my home screen. I'm going to do second mode, take me back to my home screen. Then I'm going to go back to the inverse menu. So I'm going to do second inverse, I'll go back to the matrix menu. I'm going to do second inverse, and I'm going to do some math. So the first one I'm going to talk about is the row echelon form, and I forget what number that is. Here we go. It's letter A. So I'm going to call out row echelon form to my home screen, and then I'm going to tell it to put matrix A into row echelon form. So I'm going to go back to the matrix menu, second inverse, and under the names, I'm going to call out matrix A. When I hit enter, it's going to convert that to row echelon form for me. So let's write this down. I'm going to keep in mind that these repeating decimals are, 1/3, right? This is really 1 1/3. This is negative 1/3. And what I can do with my TI is I can hit math and I can hit fraction, and it'll convert those decimals to fractions for me. All right. So there's my fractional forms for that matrix. So let's see. What do I have there? I have 1 4/3 negative, and I'm just going to be a little bit lazy here. All right, so I just did a quick little screen grab here. So here's my row echelon form of my matrix. Now here's one of the advantages to the row echelon form. If I look at row 3, right, row 3 really says to me, 0x plus 0y plus 1 times z equals negative 2. Right? So in other words, it tells me that z, not x, right, tells me that z is negative 2. And if I just kind of go backwards, right, if I look at row 2 says to me, 0x, 1y minus 1z equals 4. And we just found out what z was. Z was negative 2. So I got y minus negative 2 equals 4. And then I can solve that for y. Right? My document likes to jump all over the place for me. So I got y plus 2 equals 4, or y equals 4 minus 2, which is 2. So I have those two pieces. I have the z and the y. And again, remember, I'm plucking off each row here. So let me stop right there. Right. So row 3 told me that z equaled negative 2. Row 2 tells me that y minus z equals 4. We plugged the z in and found the y. And then let me just come over here and say, here's row 3. So row 3 says 1x plus 4/3 y minus 1/3 z equals 13/3. So if I plug in everything that I have, y is 2. So I'm going to have x plus 4/3 times 2 minus 1/3 times z was negative 2 equals 13/3. Okay. Alright, can I be honest with you here? I don't really hate to deal with fractions. Notice how these are all denominators of 3. I'm going to multiply everything by 3 here. Right? So 3 times x is 3x. When I multiply 3 to this term, it cancels in the denominator. So I get 4 times 2, which is 8. And then when I multiply the 3 here, again, cancels the 3 in the denominator. I get negative 1 times negative 2, which is plus 2. And when I multiply this by 3, the 3 cancels, and I get 13. So that was just a little quicker. I don't want to have to deal with that stuff. So I get positive 10 here. I get 3x plus 10 equals 13. And so I get 3x equals 3, or x equals 1. So there's my solution. X is 1, y is 2, z is negative 2. So x is 1, y is 2. And z is negative 2, right? And so some textbooks say that you should write that as an ordered triple, which definitely is a valid way to write the solution. Now again, let me come back to the algebra process. So we talked about at the beginning of the video, if I'm solving a 2 equation, 2 unknowns, I could graph those 2 lines. I could look at an XY Cartesian grid. I could graph the 2 lines, and I'm finding their intersection point, right? Let me scroll back up real quick. We talked about that with this system. So I could graph in the XY plane, I could find the point of intersection, I could graph those 2 lines. Now the issue here is I would have to graph these 3 equations with 3 variables, and that requires me to have a z variable. Right? That requires me to have an x-axis, a y-axis, and a z-axis. So then we're graphing in 3 dimensions. And it's usually beyond the scope of an algebra or a pre-calculus course. So you don't really graph 3 dimensions until you get to a calculus 3 course. So again, usually in an algebra text or pre-calculus text of some sort, you don't really graph. So we could check our work, right? We could take our x, y, and z, and we could plug them into each of the equations. So I'd plug in the x, y, z here, make sure I get 6 equals 6. I'd plug in the x, y, z we found, make sure we get 1 equals 1. I could plug in the x, y, z here that we found and make sure we get 13 equals 13. So that'd be one way to check by hand, since we just can't check graphically. Now there's actually a little bit of a quicker way we can do this. So instead of looking at the row echelon form, we could look at what we call reduced row echelon form. And when we're using the technology, that's actually the better way to go. Right? So let's look at the reduced row echelon form. All right, so here's what the reduced row echelon form wants. It's going to convert the matrix to where we have 1s down the diagonal. So we're going to have a 1, a 1, and a 1. And then we're going to actually have 0s below the 1s, and we're going to have 0s above the 1s. And then we're going to have some number, some other number, and some other number. So the advantage to this is pretty sweet, right? If we think of the third row, I have 0x plus 0y plus 1z equals c. So we get the z equation right away. And then row 2 says, 0x plus 1y plus 0z equals b. So we get the y solution right away. And then ditto in that first equation, we get the x solution right away. So if I'm solving this matrix by hand, usually we stop at the row echelon form and then we pull the equations out. If we're using technology, and of course we could do this by hand as well, but if we're using technology, we typically just jump to the reduced row echelon form. So let's take our prior matrix, pull my calculator back up here. Now I had already let me quit to the home screen, right? I had already done second inverse, went to the matrix, and put my matrix into matrix A. So there was my original matrix, right? So let me go back to the home screen. Let me just clear that menu or that screen. And then so what I'm going to do is go back to matrix, second inverse. I'm going to go over to math, and instead of doing the row echelon form, which was letter A, I'm going to do reduced row echelon form, which is letter B. So I'm going to choose letter B, and I'm going to do reduced row echelon form of matrix A. So we're going to go second inverse back to the matrix. Under the names menu, I'm going to call out matrix A, and I'm going to say put this in reduced row echelon form, and there's our simplified form. So we have z equals -2, we have y equals 2, and x equals 1, which is what we found from the row echelon form. All right, you guys, so let's go ahead and take a look at one other technique. And it's called using the inverse matrix is what it's called. Right? This is the inverse matrix solution technique. So let's bring back up the original matrix that we had. And this document likes to jump on me always. So let's use the inverse matrix technique. And I just want to rewrite the original matrix that we had. All right, so let's look at the inverse matrix technique here. Right, so in terms of theory, here's basically what we're going to look at, right? So let me just write this out. The original matrix that we had was 2x plus 2y plus 0z equals 6. We had 1x plus 1y plus 1z equals 1. And then we had 3x plus 4y minus 1z equals 13. So here was our original matrix. So remember, basically like this was the equal sign, right? So what we could do is write this in a slightly different way. We're going to take the coefficients and we're going to create our own matrix there. So here's all of the coefficients. We could call this the coefficient matrix, right? And if we multiply that by, let's call it the variable matrix. So if we actually, so again, in an algebra course, we're going to learn about matrix multiplication. And if I were to multiply out this matrix, I'm going to end up with this augmented matrix. And when I do that multiplication, all of that is going to equal my constants, 6, 1, and 13. Right? All right, now, conceptually, right, in a symbolic form, the way we usually write this is we would say, like, here's the coefficient matrix. So let's call that matrix A. And then usually what we do here is we call this the variable matrix. And we use X in a matrix form. And then this equals, this equals all of the constants times B. Right? So almost like in solving an equation, right? So if I'm solving for the x here, I have to get rid of the A matrix. Now, normally if these are numbers, right, if I have like 3x equals 5, I divide the 3 to the other side. But with the matrices, that doesn't work. We can't divide matrices. So we're going to use the inverse operation. So what we're going to actually do with this equation is we're going to multiply both sides by the inverse. So I'm going to take the inverse of the coefficients, and I'm going to multiply the left-hand side by that matrix. And it's going to undo this, right? So inverse of a matrix times the original matrix is 1. And again, in an algebra class, you learn about that in theory. You practice that with matrices. And then I'm on the right-hand side going to multiply by the inverse matrix times the the constant matrix. So when I take this process, right, the inverse times the original matrix just becomes 1, and I end up solving for my 3 variables. So whatever this turns out to be right here, inverse of A times B, that's going to provide the solution to my system. All right, so if we plug this into our calculator, let's take a look at what we have here. So I need a coefficient matrix, and I need the constant matrix on the other side. So let me bring up my calculator, go into the matrix menu, and then I'm going to call out matrix A that I want to edit. And then, so my coefficient matrix, I had 3 rows by 3 columns. And again, let's take a look at this. That was 2, 2, 0, 1, 1, 1, 3, 4, negative 1. So I'm going to do 2, 2, 0, 1, 1, 1, and 3, 4, negative 1. So there's my coefficient matrix. Now I need my constant matrix, right? I need this matrix over here, 6, 1, 13. So now this is 3 rows and 1 column. So let me do second mode and quit. and I'm going to go back to the matrix menu. And this time I'm going to edit matrix B. So I have a 3-row by 1-column matrix, and the matrix that we had there was 6, 1, and 13. So now let's go back to the home screen, second mode, and I'm going to type out the equation that we have here, right? So down here on the bottom, our solution is going to be the inverse of the coefficient times the constant matrix. So I'm going to call out the constant or the coefficient matrix. Let me do seconds and go to the matrix key, and I want my coefficient matrix A. And then I want the inverse of that. So right here is my inverse key. So I'm going to take the inverse of that. Then I'm going to multiply to the constant matrix B. So I'm going to go back to the matrix menu, and under the names, I'm going to call out matrix B. So when I multiply, there's the solution that we got from earlier. So we get x equals 1, y equals 2, and z equals -2. Now again, in an algebra course, you're going to learn how to do all of this stuff by hand. You're going to learn how to take a matrix, an augmented matrix, and convert it to row echelon form or reduced row echelon form. And then here we talked about the technology approach and how to check our work that way. And then this last piece, we were looking at writing the system in terms of a coefficient matrix, a variable matrix, and then the constants, right? That was how we wrote the system here. And then we used matrix multiplication by multiplying both sides by the inverse of the coefficients, and that solved as well. And again, in an algebra pre-calculus course, you're going to learn how to do all of this by hand. You're going to learn about matrix multiplication. You're going to learn about finding the inverse. But in this video, we were solely looking at how to do this with technology. All right, hope you guys enjoyed this conversation, and I'll see you in the next video.